Good morning, 8th grade. We are going to go ahead and get started on section 2 of chapter 7. I did make a review video for how to do scientific notation. I would recommend watching that before you begin this video. So we're going to go ahead and get started. Today we're going to be talking about multiplying powers that have the same base number. So let's do an example real quick. I'm just going to write a very simple one. 7 to the, 5th power. When I'm talking about, bases, exponent, power, we just want to make sure that we know the pieces that we're talking about. Okay, so I'm just going to highlight my 7 here. And when I say base, I mean the bottom number. This is my base. Okay, if I say exponent, this is the number I mean. The number up top, whatever it is our exponent. And if I say power, I mean the entire thing, base and exponent included. Oh, I didn't highlight that one. Let me fix that real quick. Exponent power. Okay, so today we're going to be talking about powers, so the whole thing, that all have the same base. The exponent might be different, but the base must be the same. So let's do a quick example before we dive into any practice problems here. So let's say I had 3 to the 4th power times 3 squared. Move this down. There we go. All right. Now I can multiply these because they have the same base. If this was differently, let's say this was 3, but this was 4, I couldn't do anything else. That would be as simplified as I could get. But since these bases are the same, there is an extra step I can take. So I'm just going to write this one out the full way so you can see why it happens, but you don't have to write this out every single time you do problems like this. So 3 to the 4th power, I know, is 3 times itself 4 times. And that is being multiplied by 3 times itself twice. So if you look, I've got 1, 2, 3, 4, 5, 6 3's. Well, I can write that as 3 to the 6th power. Okay? So whenever you're multiplying multiplying powers that have the same base but different exponents, you add them. You add up your exponents. That is why we got 3 to the 6th, because 4 plus 2 gives me 6. Pretty straightforward, right? Let's try a couple examples. All right, I'm going to hop up here. Let's make that so you guys can actually see better what I'm doing. There we go. All right, so let's try multiplying some powers. So let's say, for example, I had 12 to the 4th power times 12 to the 3rd power. All right, so the base number is going to stay the same. It's going to stay as 12. And we're going to add the exponents together. 4 plus 3 gives me 7. Okay, not bad, right? Let's try another. Let's try negative 5 to the 5th power times negative 5 to the negative 3 power. Okay, even though it's negative, you still add them. The base is going to stay the same, negative 5. Okay, and then you are going to add together 5 and negative 3. 5 and negative 3 gives me a positive 2. Okay? Let's keep going. Let's try one that's a little more difficult. let's say I had 9 to the negative 3 times 9 squared times 9 to the 6th. Okay? Even though we have 3 of them, we do the same thing that we did before. Base number stays the same. Add up your exponents. Negative 3 plus 2 is negative 1. Negative 1 plus 6 is 5. Let's do one more. Let's say I had something like this. 5 to the 3rd power times 5 to the x power. Now, it might seem like you can't do anything because you can't add 3 and x, but we can condense it a little bit. Base would stay the same, and I would just show this. And that is pretty much as condensed as that one can get. If I knew what the value for x was, I could condense that even more, but I don't, so that's about as much as I can do there. All right, let's try doing some expressions, some algebraic expressions. So multiplying powers in algebraic expressions. Okay. So, there's going to be a couple steps to these, but I'll show you what you do. So we had 4z to the 5th times 9z to the negative 12. Okay, and if you have some highlighters, I'm going to ask you to go ahead and grab them real quick. So, I got 2 here. Now, I'm going to highlight what I'm going to be multiplying together. Get out of there. There we go. So, whenever we have variables and whenever we have constants, we always put like terms together. So, I'm going to highlight what's going to get multiplied together. So my 4 and my 9 are going to be multiplied by each other. And my z to the 5th and z to the negative 12 are going to be multiplied by each other. So I'm just going to write this out the full way. You don't have to do this every time. I just want to show you what's going to be happening. So I'm going to have 4 times 9, and that's going to be multiplied by z to the 5th times z to the negative 12. Okay? So, first thing I'm going to do, I'm going to put these guys together. 4 times 9, that's going to give me 36. And then I'm going to do z to the 5th times z to the negative 12th. That is z to the negative 7th. But I remember, because we have a negative exponent, I have to put it in the opposite spot. So it's in the numerator right now. This is secretly over 1. It's in the numerator. Now it has to go down into the denominator. So that would be your final answer. 36 over z to the 7th. Let's try another. Let's say we had 2a times 9b to the 4th times 3a squared. Now for this one, you're going to need 3 different colors. Okay, so again, I'm going to highlight all the things that are going to get multiplied together. My coefficients are going to get multiplied together. My a's get multiplied together. My b, he doesn't have anybody, so he's kind of on his own. That's why he's the only green one there. Okay? So the first thing I'm going to do, I'm going to multiply 2 and 9 and 3. I'll multiply 2 and 3 first because that gives me 6. And then 6 times 9 is going to give me 54. Okay? Now, you might think you can't multiply these two because this one doesn't have an exponent. It secretly does. It has a secret 1 right next to it. if you don't see a variable if you don't see an exponent next to a variable, assume that it's 1. So a to the first times a squared is going to be a to the third. And then b to the fourth doesn't really have anything to multiply by, so it's just b to the fourth. And that would be it. You would be done. Let's try one more. I'll put it right here. Let's do 2x to the 9th times 3y to the negative 3 times 6x to the negative 10. Okay. So again, I'm going to highlight everything that goes together. You don't have to do this step every time, but if it helps you, I recommend it. And again, I have that one lonely variable who isn't going to get multiplied by anybody. But I am going to have to do something with it. Okay, so go ahead and multiply your coefficients together. 2 times 3 is 6. 6 times 6 is 36. Okay. X to the 9th and x to the negative 10th. I'm going to add those together. That would be x to the negative 1st. And then y to the negative 3rd. Now, since these two are negatives, I know I have to put them in the denominator. So I'm going to rewrite this as 36 over x. You don't have to put to the first if you don't want to. It does become a positive one, but whenever it's a 1, we don't really have to write it. Like how this a didn't have the 1 written next to it. So x, y to the 3rd. And that would be that. Alright, so that is how you multiply powers that have the same base. We're going to take a look now at something a little different. I'm going to pop up here. And we're going to take a look at some scientific notation. Because when we multiply scientific notation, we are actually using this same concept of multiplying powers that have the same base. So you have a couple cutouts. All right, this should be your first one. So I'm going to put an A, and I'm going to pause and glue that in. Oh, come on. All right, so mine is glued in. I'm going to go ahead and get started. So it says, at 20 degrees Celsius, that's not really important for our problem. It's just telling us, when it's happening. 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. That's a lot. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. Wow, that's a lot. About how many molecules of water does the droplet, which is 1.13 times 10 to the negative 7 meters cubed, of water shown below contain? Okay, so what it's saying is we've got a cubic meter of water here. We've got how much this droplet is, and we've got how many molecules are in each gram of water, which is like a ton of molecules. Okay, so what I'm going to have to do is take each of these scientific notation numbers, and I'm going to be multiplying them all together. So let's start with my droplet of water. Okay, so this is 1.13 times 10 to the negative 7. Okay, when I multiply these two, that's going to tell me how much it weighs. And by multiplying by this last one, that's going to tell me how many molecules are in that one particular drop of water. Okay, so I'm going to use my highlighters again, and I'm going to show you what we're going to be highlighting because it works kind of the same way as when we're multiplying by powers that have the same base. All my front numbers are going to be multiplied together, and all of my powers of 10 are going to be multiplied together. Okay? So I'm going to go ahead and multiply the front numbers here. All right, I'm going to multiply them. So 1.13 times 9.98 times 3.34. Ooh, I've got a long number here. I'm going to round to the nearest tenth. So I'm going to round to 37.7. So about 37.7. Okay, now the powers of 10 should be pretty simple. We know that it's going to be the same base, so it has to be a power of 10. Okay, but then we need to add our exponents. So negative 7 plus 5 is negative 2. Negative 2 plus 22 is 20. But if you've watched the review video for scientific notation, you will notice something. My front number has to be greater than or equal to 1, but must be less than 10. So this number is not obeying the rules. So what I'm going to have to do is make it obey the rules. If I make him smaller, I'm going to move my decimal point over 1. Now he's obeying the rules. If this one becomes smaller, he has to compensate by becoming 1 bigger. I moved this decimal place over 1, he goes up 1. Okay, this number became smaller, so he has to compensate by becoming bigger. If I were to write out each of these two numbers, I would see that they are equivalent, but this one is obeying scientific notation. Okay, so there are 3.77 times 10 to the 21st molecules in this particular drop of water. That's insane. That's a mind-boggling number right there. Molecules and atoms are so tiny that it's just crazy how many of them there are. Let's try another one like that. Okay, one more. Cut out. I'm going to pause and glue that in. All right, here we go. So it says a human body contains 2.7 times 10 to the 4th microliters, written as, I don't know what that symbol is, but UL, it looks like a U anyway, of blood for each pound of body weight. Each microliter of blood contains about 7 times 10 to the 4th white blood cells. How many white blood cells are in the body of a 140-pound person? Okay, so we're going to have to multiply 1, 2, 3 numbers together because 140 is how much this person weighs. And for each pound of weight, there are about this many microliters of blood. And then each microliter of blood has this many white blood cells. Now you might be thinking to yourself, Miss R, I can't multiply that. It's not a power of 10. True, I could write it as a power of 10, or I could save myself a step and realize this guy is going to get grouped together with my front numbers. Okay, if you have a number that is not written in scientific notation, he gets grouped together with your front numbers. Or you could write that in scientific notation if you wanted to, but you don't have to. Save yourself the step. Okay, and then these guys get grouped together and they get multiplied. So I'm going to take my handy dandy calculator that also doubles as a phone. And I'm going to multiply 140 times 2.7 times 7. And I am going to have to adjust this, 2,646 times, I know it's going to be 10, and these are both to the 4th, so this is going to be 8 because I add them together. All right. Now again, my front number is not obeying the rules. He's got to be between, or greater than or equal to 1, but less than 10. So my decimal point is here. I'd have to move him over. 1, 2, 3. That's his new home. 6, 4, 6. Okay. So, since I moved him over 1, 2, 3 spaces and he got smaller, this guy has to compensate by becoming 3 bigger. Okay? So this is how many white blood cells are in a 140-pound person. That's a lot. 10 to the 11th, that's a very big exponent. All right, one last thing that we're going to do today. I'm going to flip and move this over. And we're going to look at something called a rational exponent. Sounds weird, but bear with me. Okay, we're going to do an example first before we do any practice problems. So, whenever we take the square root of a number, let's say, for example, we have the square root of 16. Okay? I don't know if you got, actually, let me pull it up on my calculator because there is an example. If I turn it sideways. Yes, perfect. Okay. So, I don't know if you guys can see this all that well, but right here is my square root button, and right next to it is my cube root button. If you notice where there is square root, it's a little hard to see. Let me see if I can adjust. You can see it a little bit. There is a tiny, tiny 2 off in the corner of that square root, and a tiny, tiny 3 off in the corner of that cube root. What it means is, if I have square root, it means a number times itself twice would equal this. If I had cube root, it means a number times itself 3 times would equal this. So, secretly, there is a square root here, or sorry, a 2 there, and this is 16 to the power of 1. I can actually write this as an exponent. This is 16 to the 1/2 power. And I'm just going to use my highlighter real quick to show you how the numbers are related. Okay? And we know that the square root of 16 is going to equal 4. So 16 to the 1/2 power equals 4. It means what number times itself is going to give you 16? Well, 4 times 4 will give you 16. If I had something like the cube root of 27, okay, it's really the cube root of, whoops, forgot my tail. It's really the cube root of 27 to the 1st power. Okay, and I'm just going to use my highlighter again to show you how it would be set up as an exponent. The cube root of 27 can also be written as 27 to the 1/3 power. Okay, and if you see here, the numerator is like the exponent when it's inside, and the denominator is like how many pieces it's being broken into. So 27 to the 1/3 power, I know that the cube root of 27 would be 3. Because 3 times 3 is 9, times 3 again would be 27. So when you are taking square roots, cube roots, or even 4th roots and beyond, you can write it as an exponent. Let's try a couple. Let's say I had 81 to the 1/4 power. Okay? What that really means, my, forgot the word, brain fart, sorry. Denominator is how many pieces it's being broken into, and my numerator is the exponent inside. So what this means is, what's a number times itself 4 times and will give me 81? We actually have it written on the page already. It's going to be 3. because 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So 81 to the 1/4 power is 3. Whenever you have a fraction as an exponent, your number is going to be smaller than what you started with. Normally when you have an exponent, let me go back real quick. Oops, I went back too many pages. Like this one, 12 to the 4th power, that's going to be a very big number. But when you have it as a fraction, it might be smaller. Now it depends. Sometimes you can have a improper fraction and it might be bigger, but it depends. It depends on if you're dealing with an improper fraction or not. Let's try another one. If I had 64 to the 1/2 power, okay, that's the same as the square root of 64 to the 1st power. Okay, so we know that the square root of 64 is 8. So 64 to the 1/2 power is 8. Let's get a little more complicated here. Let's say I had this. Let's say I had that. Now here's what is actually going on, but I'm going to show you a simpler way to do it. This is what's actually happening. Remember, the denominator is how many pieces we're breaking it into. The numerator is the exponent on the inside. Okay? Now you could plug that into your calculator, but there is a simpler way to do it. And it uses kind of the reverse of, actually, let me just write it out. Confusing myself here. I can rewrite this. Can I rewrite this as 16 to the 1/4 power times 16 to the 1/4 power times 16 to the 1/4 power? Right? Because think about it. If I multiply these together, I would add 1/4 plus 1/4 plus 1/4, and that would give me 3/4. This is a little bit easier to figure out because I know each of these is going to be the same thing. So something times itself 4 times would give me 16. That's got to be 2. Okay? And 2 times 2 times 2 is going to give me 8. So 16 to the 3/4 power will be 8. Now I could go ahead and plug that into my calculator and I would get the same thing. But we can break it up into different fractions and figure it out that way as well. Alright, let's do one more. This time we're going to do one that's going to be an improper fraction, but we're going to do it kind of the same way, where we break it up into the different fractions that kind of make it up. These are called unit fractions. So let's say we had 64 to the 3/2. Okay? What's actually going on is this. It is the square root of 64 to the 3rd power. But I can think of it this way. I can think of 3/2 as 1/2 and 1/2 and 1/2. So 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. And I know that 64 to the 1/2 power is really like the square root of 64, which I know is 8. Okay, so it's really like I'm taking 8 and multiplying it 3 times. So 8 times 8 times 8. If you need to do that on your calculator, you can. I happen to know that it is 512. So 64 to the 3/2 power is 512. Okay, you'll notice because it was an improper fraction, it's bigger. This would really be like 1 1/2. My number was bigger than it. if I have a fraction as an exponent and it is smaller, my number is going to be smaller. My answer is going to be smaller, excuse me. Okay, threw a lot at you today, but that is how you multiply different powers with the same base. Take your time with this. If you need to do like a little bit of this today, maybe a little bit tomorrow or over the weekend at some point, that is fine. I am going to post my Excel practice for you guys to do as well.